So let's start with section 5.4, exponential and logarithmic equations. I'm going to jump to example 4. In example 4, they ask you to find how much the x value. Log to the base 4 x plus 1 equal 6. So log to the base 4 x plus 1 equals 6. So if you look to this example, it's already written in the log form. So we're going to convert that to the exponential form. So what I'm going to do, I'm going to move the 4 to the other side and cancel the log. That means this one is going to be on this side, the left is just x plus 1 equal 4 to the power 6. Then 4 to the power 6 is going to be 4 to the power 6 is going to be 4,096. So we're going to say here 4,096 equal x plus 1. Then minus 1 from both sides. That means x is going to be equal 4,095. That means this is the value of x. That's it for this example. So you're going to say this one is the right choice. Let's go to example 5. On example 5, they just ask you solve for x. So we're going to solve this one for x, which is 1 over 4 to the power x equals 64. Let's check how we're going to solve this one. The first thing, one of the exponents rule, it says if you have a number, 1 over a number with positive exponents is going to be the number with negative exponents. That's what I'm going to do here. The exponent here is 1, so I can write it down. This is 4 to the negative 1. Here is the x equals 64. Then I can multiply these two exponents. That means 4 to the negative x equal 64, which is 4 cubed. Now we have equal bases. That means we have equal exponents. In this case, negative x equal 3. Divide both sides by negative 1. So x is going to be equal negative 3. So this is the first way to solve this example. I'm using equal bases, equal exponents. Now in this case, if you want to solve it by using the natural log, so we're going to do the same example. What I'm going to do, I'm going to take the len to the both sides. This is x, this is y. That's me len to the x here, which is this x, equal len to the 64. Then by using the power property, I can move the exponents here. So it's going to be x len 1 over 4 equal len 64. Now I need to keep the x by itself, so I'm going to divide by len 1 over 4 so cancel this one. That means x is going to be equal len 64 over len 1 over 4. So let's check that. You're going to say, be careful here, len 64, close the parentheses, divide by len 1 divided by 4. Is going to be x equal negative 3. Both ways going to be right. We're going to use this method a lot. This is example 5. Let's do example 6. Example 6, we have len, so we can type it here, negative 3. Example 6 is len x minus ln 7, I think, minus ln 7 equals 0. I need to find the value of x. Ln x minus ln 7 equals 0. I'm going to move ln 7 to the other side. So I'm going to add ln 7 to the both sides. Cancel here. So it's going to be ln x equal ln 7. Now we have, by using 1-to-1 property, if x equal y, ln x equal ln y. I have ln x equal ln y, which is the 7. That means x equal y. So x is going to be equal 7. So that's it for this example. We're just going to plug in 7 here. That's it. The same thing with example 7. Log x minus log 10 equals 0. We're going to do exactly the same steps. I'm going to add log to the 10 to the both sides. So this is cancelled. So it's going to be log to the x equal log to the 10. Then the same property, log x equal log y, that means x is going to be equal 10. That's it for this example. So we're just going to type 10. Example 8, e to the x equal 4. So we're going to do the same property, e to the x equal 4. I can say it's ln to the both sides. So ln e to the x equal ln to the 4. Then cancel these. So x is going to be equal ln to the 4. And again, if you want to put parentheses without parentheses, it's fine. So for this example, we're just going to say ln to the 4, which is equal, x is going to be equal 1.3862. So it's going to be 6. So this is the value of x. I'm just going to plug in 1.386. That's it for this example. Example 9, ln x equal -3. Now in this case, we're going to do the opposite thing. Of course, there is 2 ways to solve this one. If you want to solve it, write down ln x as log to the base e. You can work on this one. You can say ln to the x is the same thing, the log to the base e to the x equal -3. Then I'm going to convert from the log form to the exponential form. That means I'm going to move the base to the other side, cancel the log. So x is going to be equal e to the -3. You can use this method, which is equal the second function to the ln, -3 is going to be equal 0.04497. So it's going to be 50. So 4.050. Or you can use the second method here, which is if you have ln x equal -3, I'm just going to say, let's take the exponential from both sides. Cancel here. So x is going to be equal also e to the -3. which is equal to the same result, 0.050. Both is going to be right. So here we're going to plug in 0.050. Example 10. Also, there is two methods to solve this example. The easiest one, if we have equal bases, that means we have equal exponents, or you can take ln to the both sides by saying, or by using one-to-one property, x equal y, that means ln x equal ln y. Both is going to be right. We can say equal bases, that means we have equal exponents. So it's up to you which one you're going to use. So it's going to be x squared minus 2. And I'm going to solve this one minus x from both sides. So it's going to be 0 equal x squared minus x minus 2. And that means 0 equal x 2, 1 minus a plus. So negative 2x, 1x added is going to be the middle term. That means x is going to be equal to, and x is going to be equal negative 1. That's it for this example. We're going to type 2, comma, negative 1. Example 11. We have 4 parentheses 5 to the x equal 28. The first thing, I need to solve this one for x. That means I need to keep this term by itself. But I have 4 times this term. First of all, I need to cancel this form. So I'm going to divide by 4. That means the left is 5 to the x equal 7. Now, in this case, how are we going to solve this one? We're going x equal y by using the one-to-one property. X equal y, that's mean ln to the 5x equal ln to the 7. Then next step, I'm using the power property. So move the x here. So x ln five is going to be ln to the 7. Last step, divide both sides by ln 5 to keep the x by itself. Cancel here. So x is going to be equal ln 7 divided by ln 5. That's it for this example. The next part you have to plug in. So we're gonna say ln 7 divided by ln 5 is going to be 1.209. That's it for this example. So we're gonna plug in here 1.209. We're gonna do exactly the same thing with example 12. For example 12, we have 3 e to the x equals 77. Also, we have 3 times this one, and here's the x, so I can't do anything here. So we're going to divide both sides by 3. Cancel these. So e to the x equal, I'm not going to do anything with this one. Do not type a decimal number. So keep it as a 77 divided by 3. Then I'm going to use the one-to-one property, which is if you have x equal y, that's mean ln x equal ln y. So what I'm going to do, I'm going to take ln to the both sides. I'm going to put this one in parentheses so I can know this number for the ln. Cancel these. So x is going to be equal ln 77 over 3. That means x is going to be equal ln 77 divided by 3. Is going to be 3.245. 245. 3.245. That's it for this example. So we're going to type 3.245. Let's check example 13. 6x plus 5 equals 38. 6x, 6 to the power x. Now, next step, I need to keep this number by itself because I need to solve it for x. So 6x equal 38 minus 5. So I'm going to minus 5 from both sides. That means 6x is going to be equal 33. Now, next step, I'm going to take ln to the both sides because x equal y, that's mean ln to the 6x equal ln to the 33. Then move the exponents on the top, on the other side by using the power property. So it's going to be x ln to the 6 equal ln 33. Then I need to keep the x by itself. So divide both sides by ln 6. Cancel these. X is going to be equal ln 33 divided by ln 6. That means x is going to be equal ln 33 divided by ln to the 6. And this one is going to be 1.951. That's it for this example. This is example 13. You're going to say 1.951. Example 14, we're going to do exactly the same thing, but now we have just different type. We have 3 minus 8 e to the x. E to the x equal -5. So now I need to solve it for the x. So I can't do anything with this term. And there's multiplication here. I'm going to move the 3 to the other side. So minus 3 from both sides. Cancel here. So -8 e to the x equal -8. Now I need to keep e to the x on here's multiplication. So I'm going to divide by -8. Cancel here. So e to the x is going to be equal 1. Now we're going to do the same thing. X equal y, I can take ln e to the x equal ln to the 1. Cancel these. So x is going to be equal ln to the 1. That's mean x equal 0. Because ln to the 1 equal 0. So here we're just going to type 0 for this example. Example 15, how are we going to solve this example? We have equal bases, so there is two methods to solve this one. If you say equal bases, equal exponents, you can just take the exponents to the both sides. Or you can say take them to the both sides. That means you can say ln e to the x plus 1 equal ln e x plus 8. Cancel these. So x plus 1 equal x plus 8. And then you're going to solve this one. Oh, I did something wrong. Because example 15 is not like this. Example 15 is 8 to the x. So we can't do this. That's going to be different. 8 to the x plus 8. Now we don't have different bases. So the only method to solve this one is to take the ln to the both sides. So ln e to the x plus 1 equal ln 8 x plus 8. I'm going to put parentheses here. It's not going to change anything. Cancel these. So x plus 1 is going to be equal. You're going to use the power property, move the exponents. So x plus 8, then to the 8. Parentheses, there's multiplication here. So I'm going to distribute the ln on these two terms. That means x plus 1 equal x ln to the 8 plus 8 ln to the 8. Then how to solve it for x? We're going to move the terms with the x on one side and move the number by itself to the other side. I'm going to move the 1 first. Cancel the 1 from here. So x is going to be equal x ln to the 8 plus 8 ln to the 8 minus 1. Then next step, I'm going to move this term to the left side. Negative x ln to the 8, and here's negative x ln to the 8. Cancel from here. So we're going to get x minus x ln to the 8 equal 8 ln to the 8 minus 1. Then next step, I'm going to get the common between these two terms, which is x. The left is going to be 1 minus ln to the 8 equal 8 ln to the 8 minus 1. Then the last thing, we need to keep the x by itself. So we're going to divide by 1 minus ln to the 8, 1 minus ln to the 8. Cancel these. That means our x is going to be equal 8 ln to the 8 minus 1 over 1 minus ln to the 8. That means x is going to be equal, we're going to 8 ln to the 8, close the parentheses, minus 1. It's going to be 15.636. I'm rounding the number to 3 decimal places, and 1 minus ln to the 8 is going to be negative 1.07 94079. Now divide this number, divide by this one. The result is going to be x equal negative 14. X equal negative 14.485. This is the value of x. That's it for this example. We got it right. Let's move to example 16. Example 16, we have e to the x, e to the 2x, minus the 3 e to the x, minus 10 equals 0. So it's a tricky example with this one. How are you going to work on it? First of all, we already know every time when we have a number with the base n times a number, different exponents, like same base, different exponents, you're going to say it's a n plus m. You're going to add the exponents. When you multiply two numbers, you're going to add the exponents, but it's supposed to be the same base. If you look to this one, e to the 2x, e to the 2x is e to the x times e to the x. When you multiply the same base, you're going to add the exponents. X plus x is going to be 2x. That means if I look here, this is e to the x times e to the x. 10, I can say this is 2 times 5. I can use this one to factor these equations. I'm going to open two parentheses, equals 0. I'm going to say e to the x, e to the x. When I multiply these, it's going to be 2x. And I'm going to say 5 and 3, 2. Put minus here and the plus here. Now let's check. These two terms, negative 5 times e to the x is going to be negative 5 e to the x. E to the x times 2 is going to be 2 e to the x. Add these together, it's going to be negative 3 e to the x, which is the middle term. This is just to prove we did the right option. So now e to the x minus 5, e to the x plus 2 equal 0. Let's solve this one. That's mean e to the x minus 5 equals 0, or e to the x plus 2 equal 0. You're going to add 5. That means e to the x equal 5. On the other side, you're going to minus 2. So here is going to be e to the x equal negative 2. Until now, we didn't solve it, because now we need to find the value of x. So what I'm going to do, I'm going to say ln e to the x equal ln to the 5. Cancel here. That means x is going to be equal ln to the 5. X is going to be equal ln to the 5, which is equal 1.69. 1.609. The same thing on the other side. You're going to take ln to the both sides, equal ln to the negative 2. So x is going to be equal ln to the negative 2. If you plug in this one in the calculator, ln to the negative 2, domain error, because our domain for the ln function is from 0 to negative infinity. We can't take negative number, so this one is going to be error, is undefined. So you can't choose this one as a solution. That means the value of x is going to be 1.609. So we're just going to type here 1.609. Now, we already know everything here is just a number. So this number is, if you plug it in the calculator, is 0.50 divided by 12, and you're going to add 1. So it's going to be 1.04041667. I'm going to take that. This number, I know you're going to round it, t equal 4. So the next step, we're going to take the ln to the both sides. That's mean ln to 1.041667 for the 12t equal ln to the 4. The next step, we're going to use the power property. So it's going to be 12t ln 1.041667 equal ln to the 4. Next step, I need to keep the t by itself, and there is multiplication between these numbers. So I'm going to divide by 12 ln 1.041667, and here's also 12 ln 1.041667. Cancel the ln with the ln, 12 with the 12, the left is just t equal. Use the calculator, is going to be 2.830, and be careful when you plug in 2.830. You have to round the number, and let me show you how you're going to plug in. When you plug in this one, you're going to say ln to the 4, close the parentheses, divide by, open another parentheses, 12 times ln 1.041667, close the parentheses, close the second one. So it's going to be 2.8299. Round this number, add 1 here, it's going to be 30. 29 is going to be 30. That's mean 2.830. That's why I got it right here. Let's go to example 18. Let's check example 18. Example 18, it says 3 plus 9 ln x. 3 plus 9 ln to the x equals 7. Now I need to find the value of x. So I'm going to move the 3 to the other side. So I'm going to say minus a 3 from both sides. So it's going to be 9 ln to the x equal 4. Then I need to keep the x by itself. That's mean ln x. So divide both sides by 9. So it's going to be ln to the x equal 4 over 9. Then take e to the both sides. Cancel these. So x is going to be equal the exponential function 4 divided by 9. That's mean x is going to be equal the second function for the ln, and 4 divide by 9 is going to be 1.5596. So it's going to be 1 point, count to 3 decimal places. Yes. So it's going to be 1.560. That's it for this example. We're going to type here 1.560. We got it right. Let's go to example 19. Example 19, we have 7 log to the x minus 6. 7 log to the x minus 6 equal 13. So the same thing for the first, there's multiplication here. I need to keep the log by itself. So I'm going to divide by 7. So it's going to be log to the x minus 6 equal, just keep it 13 over 7. Then let's check what's the next step. There's 2 ways to solve this one. You can say the base here is 10 and move the 10 to the other side, or you can take the log to the both sides. So I can say this is the base is 10 and move the 10 to the other side, because this is a common log. So the base here is 10. So I'm going to say this is log to the base 10 x minus 6 equal 13 over 7. And then convert to the exponential form. So I'm going to move the base to the other side, cancel the log. That means x minus 6 is going to be equal 10 to the power 13 over 7. That means x minus 6 is going to be equal. Let's just add 6 to the both sides. We're going to add 6. We're going to add 6. That means x is going to be equal 10 to the power 13 over 7 plus 6. That's it for this example. Then next step is going to be 10 to the power 13 divided by 7. Go down here, you're going to add 6. So it's going to be 77 point, round to 3 decimal places also. So 969. That's it for this example. Here we go, we got it right. Let's move to example 20. Example 20, how are we gonna solve this one? Because I have ln here and ln here with the plus sign, and there is no ln on the other side. So what I'm going to do here, I'm gonna say use the product property. If I have ln x times y, is going to be ln x plus ln y. So I have this side. So that means this is going to be equal ln x times x plus 1. I put parentheses here for the ln, equal 4. Then you can distribute here, it's fine. It's going to be ln x squared plus x, or you can keep it like this. It's up to you. So it's going to be ln x squared plus x by distributing everything here inside, equal 4. Now I need to cancel the ln here. Again, you have 2 ways to solve this one. You can write down the ln as a log to the base e, or you can just raise both sides to the exponential. That means I'm going to say e to the ln x squared plus x equal e to the 4. So cancel the ln with the e. So it's going to be x squared plus x equal e to the 4. Move e to the 4 to the other side. So it's going to be x squared plus x minus e to the 4 equal 0. In this case, we're going to use a quadratic formula. So you're going to say a equal 1, b equal 1, and c equal negative e to the power 4. I'm not going to do this one. You just have to find the value of x by using the quadratic formula, which is x is going to be equal negative b plus or minus square root of b squared minus 4 times a times c divided by 2. Here's the formula. Plug in these values here. And don't worry about this one. This is just a number. You can plug in the calculator and to get it. But do not plug in now. Keep it e to the power 4 until the last step. You can plug in how much is going to be e to the negative 4. (21) and the 22 are exactly the same way to solve it. So I'm going to solve example 22. We have ln x plus 6 minus ln x minus 3 equal ln x. So we have minus between two ln. That means this is going to be division. So it's the same thing, ln x minus plus 6 over x minus 3 equal ln to the x. Ln x equal ln y, that means x equal y, the one-to-one property. So cancel these. So it's going to be x plus 6 over x minus 3 is going to be equal x. Multiply by the least common denominator, which is x minus 3. So it's going to be x plus 6 over x minus 3 times x minus 3 equal x minus 3. Cancel these. So it's going to be x plus 6 equal x squared minus 3x. Now minus 6 from both sides. Cancel here. So x is going to be equal x squared minus 3x minus 6. Minus x, in this case, so minus 3x minus x, this is cancel 0. It's going to be x squared minus 4x minus 6. You can't factor this one. You have to use also quadratic formula. Let's try that. A equal 1, b equal negative 4, and c equal negative 6. So the formula, it says x equal negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. So it's going to be x equal negative b, which is negative 4, plus or minus square root of b squared. So it's going to be 16 minus 4 times a times c, which is negative 6, divided by 2 times 1. That means x is going to be equal 4 plus or minus square root of 16. Negative times negative is going to be positive. So plus 24. 16 plus 24. Plus 24 over 2. This one is going to be equal 4 plus or minus square root of 16 plus 24 is going to be 40. over 2. So x is going to be equal 4 plus or minus square root 40 is 4 times 10 over 2. And this one is going to be equal 4 plus or minus 2 square root of 10 divided by 2. X is going to be equal, take the 2 as a common, so it's going to be 2 plus or minus square root of 10 divided by 2. Cancel these. That means x is going to be equal 2 plus or minus square root of 10. I don't think so. You can plug in this one. Yeah, you have to plug in as a decimal. So 2 plus square root of 10 is going to be, you're going to get 2 plus square root of 10 is, that means x is going to be equal 5 point, the one with the plus is going to be 5.1622, and 2 minus square root of 10 is going to be negative 1.1622. 1622. That's the solution for example 22. Here's one thing, we can't take the negative, because if you plug in negative number in the len x, not here, not here, here, len to the negative number is going to be undefined. That's why we're going to cancel this one. The solution is going to be only 5.62, because we're going to round to 3 decimal places. This is example 22. For example 23, we're going to do the same thing. We're going to use the product property, plus between 2 log. So it's going to be log to the base 3 x times x plus 4 equal log to the base 3 x plus 54. Cancel the log from here and from here, because log x equal log y, that means x equal y. So it's going to be x plus 4 equal x plus 54. Distribute here, so it's going to be x squared plus 4x equal x plus 54. Minus x from both sides. So it's going to be x squared plus 3x equal 54. And then you're going to minus 54. That means x squared plus 3x minus 54 equals 0. Now we can factor this one by opening 2 parentheses equals 0, x 9, 6 plus minus. 9x minus 6x is going to be 3x, which is the middle term. That means x plus 9 equals 0. So x is going to be equal negative 9. And x minus 6 equals 0. That means x is going to be equal 6. I can't choose 9 because I plug in 9 here. Negative 9. Log to the base 3 to negative 9 is going to be undefined, because our domain from 0 to infinity. So our solution is going to be just 6. There we go, we got it right. Last question, 24. 24, 1,000 invested in an account at interest R equals 0.045, compound continuously. So the invest is 1,000. The rate is 0.045. They ask you to find the required for the amount to double. That means our future amount is going to be double this one. Double this one, that means the future is going to be 2,000. We need to find the time. So in this case, to find the time, compound continuously, that means we're going to use the formula A equal PERT. We have now everything. We need to find the time. We have, so it's going to be 2,000 equal 1,000 E. The rate is 0.045 T. Now, there's a number with the exponent. So we're going to cancel this one by divide both sides by 1,000. That means 2 is going to be equal e to the exponent 0.045 t. Now, next step, we need to find the t, and there's exponential. So I'm going to take ln to the both sides. That's mean ln to the 2 is going to be ln to the e 0.045 t. Then cancel these. So it's going to be ln to the 2 equal 0.045 t. To find the t, we're going to divide both sides by 0.045. That means t is going to be equal. You're going to cancel these two. T is going to be ln to the 2 divided by 0.045. It's going to be 15. They ask you round your answer to 2 decimal places. So 1540. 15 years and 40. Here we go. We got it right. We're going to do the same thing, but find the time required to amount to triple. That means 3 times. That means now this is A, B, to triple the amount. That means our future is going to be 3 times the invested, which is 3,000. So it's going to be 3,000 equal P, which is 1,000, E 0.0545 T. The same thing, you're going to divide by 1,000. Cancel these. So it's going to be 3 equal E to the 0.045 T. Now we're going to take the ln to the both sides. So it's going to be ln to the 3 equal ln e to the 0.045 t. Cancel the ln with the e. So ln to the 3 is going to be 0.045 t. Divide both sides by 0.045. That means t is going to be equal. You're going to say ln to the 3 divided by 0.045. It's going to be 2441. 24.41. And here's the first one. Here we go. We got it. That's it for section 5.4.